Cool. So, welcome to this episode in our series. And in this episode, my goal is to show you how to read colored images and convert them to grayscale. Like I told you in the previous video, it is good to understand how images are represented, how colored images are represented, and how they are different from grayscale images. But it is also important to know how to convert a colored image to a grayscale image, because in most of the manipulations that we perform on images, as far as computer vision with OpenCV and other libraries is concerned, we like to do these manipulations on grayscale images because, like I told you in the previous video, grayscale images stores values between 0 to 255 as pixel values, and 255 is white, 0 is black, and anything in between is a shade of gray, approaching white as you approach 255 in the positive direction and becoming black as you approach 0 in the negative direction. And because it doesn't have multiple channels, the mathematics involved in manipulating these images is simpler and less resource intensive as far as computing resources are concerned. Okay, so what am I going to do here? I am going to show you how to convert an image into grayscale. So, like usual, we are reading Ronaldinho's picture from our file system, and feel free to use any file you get to. You can use any image. It could be PNG and JPG, any image format you are interested in. You can do that with OpenCV. So, how do we convert an RGB image or a colored image? So I'm converting colored image to grayscale. Okay, and this is how we do it. So I'm going to call it gray is equal to cv2.cvt color. Okay, and what you do is you give it the colored image which we read from disk, and then you say cv2 dot color, and then you say bgr2 gray. So I've been talking about RBG, but you are seeing BGR here, and that is because OpenCV stores the channels in BGR formats, like it is reversed instead of RGB. Okay, so anytime you try to split a colored image into 8 various channels, you get the blue first, the green, and the red first as far as OpenCV is concerned. And this is very important to keep in mind, because most of the time you use OpenCV with other libraries that treat colored images in the format RGB instead of BGR that OpenCV is doing, and this causes a distortion, like you saw in the example where I loaded an image from the URL, and you could see that the colors were not matching what you could see on the site. Okay, so this image here, because we are using cv2.imread, it is coming in the format BGR instead of RGB. So what this function cvt color is doing is you are saying convert color of this colored image from a BGR to a grayscale image. So over here we are showing let me call this original, and then I'm going to copy this, and then I will show the grayscale version. Okay, so over here I will show the grayscale version, and let's run this and see. So as you can see, this is the grayscale version of the image, and this is the colored version of the image. So what the OpenCV library did was to convert each pixel here from RGB, which is of course, let me do this correction, this is BGR for OpenCV. It does its magic mathematics that has to be done to end up with an image that has only a single channel, but it has the same width and height as the original image, and the result is a grayscale image that has values between 0 to 255 for each of the pixels that is obtained from the colored image here. Okay, so this is how to read a colored image and convert it to a grayscale image. Actually, it is one way to do that. I'm going to show you another way. So let me kill these guys and then I'll show you another way. So in the OpenCV documentation, it talks about how to use cv2.imread, and it turns out that it actually takes a second parameter, and with that parameter you tell it how to load the image, whether you want to load it as colored, you want to load it as grayscale, or you want to load it unchanged. Okay, and these are constants that represent integers that can actually be supplied to the function. And in many cases, using this approach is faster than reading the colored image and then later converting it to grayscale, but it depends on what you are doing. If you have any business with a colored image, if you want to do some manipulations on it before you convert to grayscale, then you have to use this approach here. Otherwise, you are free to do this. So I could come here and I could just say cv2.imread. Come on, yeah, and read grayscale. Good. So immediately this line is executed, we would have this image here in grayscale, regardless of the fact that the original image is a colored image, because we said it should read it in grayscale. So we wouldn't have to perform this conversion here. Sorry, we wouldn't have to do this conversion here, and we wouldn't have to do this. So let's try this out and see if it works. And voila, so you can see that it actually loaded the original image, but it converted it to grayscale immediately. Okay, so this is also another way of reading images as grayscale. And remember, OpenCV treats the channels as BGR instead of RGB. Remember this. Thank you very much for watching, and see you in the next video.